Welcome to ClickMyProject.com. Now we are going to discuss about the project E-Key and EEG-Based Biometric Authentication and Driving Fatigue Detection System. Now we are going to discuss about the abstract of the process. The processing and analysis of EEG signal within a proposed framework has been carried out with the discrete wavelet transform and then the machine learning algorithm. The signal frequency is decomposition into one sub-bands like alpha, beta, gamma, theta and delta, and a set of the statistical features were extracted from the sub-bands by the wavelet's coefficients, that is nothing but the discrete wavelet transform. After that, the reduction of the dimension of the data is done with the help of the principal component analysis, that is the PCA, and independent component analysis, that is the ICA. Then these features were used as an input to the machine learning for the classification method of the data as a normal or the fatigue. Whether the input signal is the normal, the message box will be indicated as a normal. Otherwise, if the signal is a fatigue signal, in the sense the message box will be alert as abnormal or fatigue data. After doing the classification, the performance of the classification process is evaluated due to the different methods is presented and then compared to show the excellence of the classification process by the parameter called accuracy. Hence, the accuracy is high, in this sense the classification rate is high and the efficiency of the process is also high. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. This project consists the modules such as input signal, pre-processing, feature extraction, feature matching, that is nothing but the classification, then finally the performance estimation. These are the 5 modules included in this project. At first, the input signal is taken from the dataset. Dataset is the folder which consists of both the normal as well as the abnormal signal. The user can select any one signal from the dataset. After doing the selection of the input signal from the dataset, the pre-processing will be carried out. Pre-processing is nothing but to remove the noises present in the signal, as well as it will decompose the data into an alpha, beta, gamma, theta and delta. These are the subbands present in the EEG signal. After doing the splitting of alpha, beta, gamma, theta and delta, we have to extract the features from the above subbands. So we have to apply the feature extraction in the next step by means of the feature encoding by 3 stages. One is ICA, then the another one is PCA, then the third one is the DWT. Using these 3 algorithms, we are going to extract the features from the signal. After doing the extraction of the features, those features are considered as a test feature. The reason is the feature is extracted from the single input signal. That's why the feature schemes from the input is test feature. During the classification, the train feature and labels are included. Train feature is nothing but the features of the all the dataset signals. For example, I have hundreds of signals in my dataset. In the sense, those hundreds of signals will be extracted. So those feature is the train feature. After doing the extraction of the train features, we just import the labels also. That is belongs to the category of the number of classifications. After importing all the thing, the feature matching is done by using the machine learning algorithms. So in this machine learning, it will classify whether the input signal is normal or abnormal. Abnormal in the sense fatigue signal. After doing the classification, the performance will be evaluated by means of the 3 parameters named as accuracy, sensitivity and specificity. By these 3 parameters, we can justify our process is good. Now we are going to discuss about the running procedure of the process. At first, open the Matlab 2019b and then change the current directory. If you want to execute the process, just right click in the main_100.m and select the option run. Once you selected the option run, the dataset folder will be open automatically. In that dataset folder you can see the several data files which is having the several kinds of EEG data. You can select any one data from the dataset. After doing the selection, the process will be done automatically, so the results will be shown one by one in the figure window as well as in the command window. Yeah, now the overall process was completed within a fraction of seconds. Now we can see the results one by one. This is the input signal which we have imported from the dataset. So user can select any signal from the dataset. After the selection of the signal, those selected images shown in the figure 1 with the title of input signal. After doing these selections, we just do the noise filtering. So the noise filtered signal is shown here in the figure 2. That is a kind of pre-processing also. So before going to this result, we can see the results of alpha signal, beta signal, gamma signal and theta signal. So these are the table values which represents the signal data of the alpha, beta, gamma, theta and delta. So these are the values which represents the subbands values of the signal amplitudes. After extracting these subbands, we have to extract the features from that subbands. So this is the features belongs to the ICA, this is the features belongs to the PCA, then this is the features belongs to the DWT. So after doing the extraction of the everything, we just doing the subbands as an wavelet decode and wavelet DWT decode, that is the discrete wavelet transform decode type. After extracting the each feature separately, we have to combine every features as an unique features. We have to combine everything as an test one. This is the test feature we have extracted. Now the final stage of the project shows this is the normal signal or abnormal signal. In case of normal, it will shows the normal signal. In case of abnormal, it will shows the fatigue signal.